Hi folks, in this video we're going to have a look at the risk equation that we use to calculate how much at risk people are from natural hazards. This is very important in geography and could be used all the way through the A-level course. So, first off we need to think about what is this risk, how do we calculate it, and what implications does that have for people and places. DEG in 1992 came up with a model known as the DEG model, funnily enough. It gives us some idea about what a hazard is and what a disaster is. And these are the two things that we think about when we think about risk. So are people at risk of hazards? Are people at risk of disasters? And DEG decided that a disaster was if you've got an overlap between a hazard and a vulnerable population. So a hazard is where you've got an event, so something that happens in the world, could be caused by people, could be caused by the natural world, whichever way it is, you've got an event that puts people and property at risk, basically. So if it's likely to affect those people, if it's likely, an event that's likely to affect people, it's a hazard. But if you've got a bunch of people who are vulnerable, the people who are at risk of being affected by this hazard, then we call that a vulnerable population. And that's the other part. And if the two overlap, so if you've got a hazard that puts people at risk, and you have got a vulnerable population that overlap, that is where you get a disaster forming. And disasters are big issues. We need to be aware of them, and we need to figure out how much at risk people are of being affected by them. So this model is a good start. It gives us some idea to say, well, if you've got a hazard and you've got a vulnerable population, you're going to get a disaster. But how can we be a bit more precise? The risk equation is a really useful way of being more precise about it. Now the risk equation operates in a kind of mathematical way, so with multiplication and division, coming to a figure at the end. So risk is equal to this formula here. Hazard and vulnerable population are the first two aspects. So if you multiply your hazard by your vulnerable population together, that creates essentially your disaster, going back to the DEG model. The hazard itself can be broken down a bit further into both frequency and magnitude. Frequency, how often these things occur. Magnitude, how big they are. So if you've got lots of small hazards, it might not actually be as bad as one massive hazard. So that's the top line, that is the disaster itself. But risk isn't just about disaster, risk is about how much that disaster actually affects people and how they recover from it. And that's where this comes in, this is capacity to cope. CC is capacity to cope, that's how well people can cope with the disaster, how well they can manage it. Do they have, for example, a good government to look after them? Good houses and infrastructure that will withstand a disaster? Have they got enough money to look after themselves? And that creates our risk equation. We divide this disaster aspect, hazard and vulnerable population, by the capacity to cope, and that gives us an idea of risk. Now there's no exact units for this. You don't have a unit of risk, a unit of hazard, a unit of capacity to cope. It doesn't work like that. What we do though is we just use it as a guideline. We can think, okay, is the hazard bigger, the vulnerability bigger, the capacity to cope bigger? So, to recap, we've got risk, hazard, frequency and magnitude, which will link into the hazard, vulnerability, and that's divided by capacity to cope. And I've got a couple of examples on the board for you. These are just hypothetical examples. We might think about, say, two different areas. you'll notice I've put hazard at about the same size in each one. That's so that we can compare the risk outcome. So, we've got hazard 1 in area 1, and the vulnerable population, okay, it's a reasonable size. So hazard times vulnerable population, okay, we're going to get a bit of a disaster here. But we've got a big capacity to cope. They're ready for the disaster, they've got plenty to deal with it. So the risk, when we take these two and divide it by that big capacity to cope, it's actually quite small, really, which is good. However, in area 2, we've got same sort of size hazard, but the population is much more vulnerable. So they could be closer to the hazard, there could be more people living in the hazardous area, and they haven't got the capacity to cope, so they're much poorer perhaps, or the government isn't prepared, or they're not prepared. Might have even ignored the government, who knows. But the point is, that is a much smaller number to be dividing by. We're multiplying those together, and that's much smaller. So the risk comes out much bigger. So this is really how we use the risk equation. We think about hazard and vulnerable population, creating a disaster, but how ready are those people for it? And that gives us our idea of risk. We're going to have a think about some real examples, some real areas in class and in further videos. But it is important to get your head around this, especially the key terms up here. Any questions, let me know. Thank you very much.